Hello, everyone. Welcome to another stream of Creative on YouTube. And today we have our beloved guest, Miguel, with us again. Hi, Miguel. How are you doing?
Hello, I'm very well. Um, I'm excited for this chat today, and
Long time
yeah,
no see.
yes, indeed, yes, indeed.
It's been a lot of time. I don't even remember when our last stream was. We were talking about design systems, right?
Yeah, it was probably around a year ago,
I
12
guess
months ish. Yeah,
time literally
time
flies.
flies.
Yes. So
But we
for
did
the
a lot of stuff in the meantime, so exciting.
obviously, full disclosure, we're working together with Miguel at Neol, and like we're literally talking every day. And when I say like long time no see, it's for this channel. It's at Coyote's YouTube channel where we had our last stream. That I think that was a very insightful stream on design systems. So, like, if you're ever interested in hearing more about what we think, how a design system should look like, should feel like, should be programmed, should be architected, definitely watch that video on the channel as well. And maybe for the first time viewers, we can remind ourselves a little bit. I'm Arman. I'm the founder of Coyote, and I work as a CTO at Neol, which is a separate company. And I like to talk a lot about software. I teach software and I participate in open source a lot. I have a lot of libraries, especially thanks to vibe coding now. Like I crank out a library a day. And um, yeah, that's very briefly about me. I live in Berlin, Germany, and I also like to take part in the local tech scene. Miguel?
Yeah, I'm Miguel. I do software since I'm 18, so like
Oh,
over
you're
15 years
21
now.
now.
Yeah. yeah, I like building software because I like that computers do exactly what you tell them to do, except LLMs.
Ooh, that's
and
foreshadowing.
and yeah, I live in London at the moment. I'm married to a beautiful wife. I do not yet have kids, but yeah. And I also have a cat, so if during the stream you might hear some background meowing, that's going to be Hamilton for you. And yeah, I'm excited to be here.
Why
And
is your cat named
yeah,
Hamilton?
oh, because of the musical. I like the musical a lot, and it's a cheeky name, and he's a cheeky cat, so it kind of fits to his character. Yeah.
Perfect. So well, let's maybe talk about why we're doing this stream, where it came from. Actually, it's very similar to the first stream. We were back then discussing design systems and like passionately in the middle of the night, and we decided, hey, we should turn this into a live stream because we both have our YouTube channels. By the way, we both have our own YouTube channels. We're not only inside this box at Coyote, but we have like I have my own channel. Miguel has his own channel. We're doing our own thing. So please like and subscribe. I don't say this in my own channel, but I think I can say this in Coyote's. Um, and we said like we should turn this into a YouTube stream because it's like an area where there's a lot of misinformation, and we believe we can contribute to the field with our discussions, which is practically what happened like last week, 2 weeks ago, when we were
Mm-hmm.
passionately discussing LLMs and how to work with them. In half an hour, we discussed a ton of things, and unfortunately, we don't really have a recording of it.
Yeah.
And
Such a
we,
bummer.
yeah, we thought it would be a cool idea to kind of like recreate portions of that discussion here,
Mm-hmm.
so that maybe like we can also expand on some of the topics a little bit, and we share with the world as well what we really think of the best ways of using large language models and building AI agents or prompting them for like better daily chat and then workflows and so on and so forth. And fast forward 2 weeks, and here we are. hoping to discuss this topic at length.
Yes,
Um,
yes.
how should we start? Maybe we can
Maybe we
talk
can.
about like our joint experience with large language models, like why we're interested in this topic.
Yes. I think LLMs solve a problem that has been unsolved for the majority of computer existence of computers. Basically, processing natural language and interpreting natural language. If you try to do this without an LLM, you probably end up with a file with 100,000 if statements, and it still is not good enough. And also semantic understanding or semantic mapping. It's a very hard problem, extremely hard problem. And LLMs are like this magical black box that just solve it. They seem to solve all our problems on the surface. So yeah, I think this is what makes it very exciting to work with LLMs for me.
Until they don't solve them, right? They solve them until they don't solve them. And I guess like this is what we're going to talk about today, do's and don'ts of like working with large language models or prompting them. And there are very clear um, breaks in its execution, its intelligence, that prevents it from going on in fulfilling what you do. And like one magical thing, of course, is they are so believable in a lot of the use cases, and you think they can do much more. And then like you are annoyed and frustrated, heartbroken, even when you see like they completely, utterly fail in what's seemingly a very simple task. That a normal human being who would do A would definitely do B somehow like does not really apply to large language models. And we've been struggling with this for a very long time as well at Neol, which is a an AI first company for how do we define Neol?
Yeah, I think it's using natural language to explore your network and maybe your future network. Yeah.
What is a network in this case?
I would say a network is all the people you know and you yet will know in the future to build professional relationships with. And I think a lot of people have very interesting connections, but also those connections are not really utilized, are not really visible, and are not really, unlocked properly.
Right.
And this is the problem we try to solve with AI. Yeah.
Basically, like giving you the ability to sort through, understand, explore, make sense of, and connect with your human network.
Yes.
Could be LinkedIn network, could be others that you're maybe part of. And the way, of course, we use large language models there, it's an entire journey, I guess. How did we start? We started with something called an approach builder. I think the very first large language model application that we built was not a chatbot. It was an actual multi-agent collaboration system where you'd be working with an account manager to go through your network, and it would practically find the best matches based on a given criteria. And then we decided to do a Slack bot and open this up to our Slack community because we have a very large community of creative leaders, is what we call them in the industry, with a lot of experience and background. And we wanted to make it easier for them to connect with one another. And since it's a Slack community, I think the goal was to bring the product where the people are. So we decided to build a Slack bot. And that went super well. And we immediately started working on a new product that is like, again, AI first, end to end, enabling network. I would say, I don't know how to put it, but gives a meaning to your network
Hmm.
and
Hmm.
adds a meaning to your network or the people in your network based on your needs and your perspective maybe. And fast forward about a year, maybe a year and a half, and we're now at a stage where it practically works like magic in finding the right people in your network. With every company we tested, every person from like all different verticals of like different industries, different lifestyles, workforces, they're like, oh yeah, those are the people that I would also come up with if you asked this question to me. So like there are now a network of AI agents that are collaborating in the background while processing your request that practically gives you insights that only you would maybe remember about a person. And of course, if they're not really a
Mm.
close acquaintance, you would never know about their fit for a particular task, for a particular industry, any requests, any interest area that you might have. Somehow, like magically, you find the right people. So it's fair to say, while building this array of 15 plus AI assistants or AI agents, we have run into several caveats of large language models and found like some best practices. And that's practically what we want to talk about today.
Yes, yes. Um, yeah, I think also that initially when you start using LLMs, it almost seems to be too easy to be true, too good to be true almost. You're like, oh, of course, we can add this all together. And you test it and it works.
Mm-hmm.
And you are very happy. But then you start testing more cases and more, you repeat your experiments, and
Mm-hmm.
suddenly it fails. And it's like a surprise Pikachu face reaction that I also personally had, where it's literally not possible for me to comprehend why this would fail in the moment it happens. Which is, I think, very different to traditional software development, right? Because you can set
Right.
breakpoints in your tests, you have unit tests, and you can clearly understand and narrow down exactly to the line of code that causes the bug. And here we don't quite have this. So it's a very interesting problem.
And with like traditional software engineering, what works is the code that you write. There's nothing else that's running. So something you didn't write is not running. And in a large language model, there's a prompt that you write, but then obviously it's trained on petabytes of terabytes of petabytes of data, which is always dangerous because like it knows so much more than what you tell it to. There was this character, what was it called, Marvin, the paranoid android in Hitchhiker's Guide to the
Hmm.
Galaxy,
Yes.
like brain the size of a planet, and they ask me to translate a sentence into this other language, or and they ask me to summarize their homework or a book for their homework. It's practically that kind of a situation. So you never know what's going to show up in the response. So
Yeah.
maybe let's start by discussing those things, or maybe like let's go through the simple mechanism of a large language model. How does it work, and how does it decide what's going to show up? Because I think that's going to really illuminate our path when we discuss the do's and the don'ts.
Yes. Yes. So I think it all started with this, or the LLM revolution started with this one paper. Attention is all you need. And before that paper, you could still generate text token by token or, yeah, word by word. But it was very difficult to keep the entire text consistent and logical and structured. And
Mm-hmm.
with this paper, it actually unlocked a new world where actually the entire context window influenced every token that gets generated. And yeah, I think this might be very difficult to grasp initially, but an LLM, when it generates text, will not know the word it will generate after the next one. It only knows the next one. So, and this is, I think, a very, very new concept to grasp for a lot of people, because it seems to be like different to how we think as humans. Because when I think about, for example, the words I'm currently saying, I already have in my head the outline of the whole thing in my head. LLMs don't, and yeah.
Which might be a diffusion model, right?
Yes.
Like you have a vague concept of the entire thing that you're going to say, and as time gets closer, or as you process it more, it becomes more and more clear, which is like the reason I brought it up is because it's an active area of study. Large language models that we use today are called autoregressive models, where it acts like a recursive loop where the token to be generated depends on the values, the tokens that came before that. So obviously, for the token that should come after that, the one that you last generated gets added to the stream, and now all of the previous tokens affect the next one. So this is almost like a recursive loop that's going on. So we do this token by token, and it's very important. Like I think the entire key that we need to take out of this stream maybe is attention is all you need, attention is all you got, and attention is all your problems. And you're practically working with someone who has problems with their attention, so you never know how they're going to tie what they knew back then into this new concept. So you really need to guide it and hone it very tightly to produce the output that you're looking for. Even though obviously like they can generate thousands of tokens or words per minute, doesn't matter. It always happens in this looping method where there's only one next token and everything happens or everything affects that next token. Whereas in diffusion models, what happens is just like image generators like Midjourney, or like other stable diffusion, which practically started this revolution, is you basically start with noise and maybe a predefined length or a bracket of length for a certain generation. And it is also an iterative model, but on every iteration, instead of adding to that initial data set, you're refining it. You're removing the noise and letting it turn into more and more clear structures. That's why in like, for example, stable diffusion or Midjourney, you start with a very blurry, bleak image, and then it gets clearer and clearer as more details appear. And there are a couple of language models that are already doing this, which is crazy for code creation. Like you see it inserts just blobs of empty space or whatever, and then suddenly characters start appearing. Suddenly, like for most of that run, you see a syntax error basically, because like the curly brackets are wrong, statements are wrong, etc. But at the end of that run, which happens much faster than traditional LLM autoregressive model generation, you find code that is pure, pristine, very clear, and practically like abiding all the rules in that file that you might have, like for linting rules or whatever, which is really mind-blowing. And I'm really looking forward to diffusion models in text entering our lives and taking a bigger chunk. And obviously they have their own problems of resolution, of attention mechanism, because that's also very limited in a diffusion model. This is also why you end up with 6 or 7 fingers instead of 5 on Midjourney, for example, because it doesn't count, because it's
But it
not
has a very high resolution. It's
yeah,
very high quality.
very high quality 6 fingers, because practically it's not creating fingers one by one. It's not counting. It doesn't know. So, all right. The first fact that we need to define and set then is, in at least like today's large language models, in an autoregressive way, what happens is there's an attention mechanism, which means the entire context window, all the tokens that it has created so far, are used in the same equation, in a simple equation, to predict the next token. So this is fact one. All the context window affects the next token, and this goes on in a loop. But what does that actually mean for us? Like, what are the problematic areas that this introduces to our lives?
I think one problem for sure is the context window management, or the prompt engineering or context engineering.
Yeah, they call it context engineering right now, because it finally, thankfully, after years, people figured out that it actually could be dynamic. Like, you don't really have to insert one single giant system prompt. But yeah, let's maybe talk about why that thing is important.
Yes. So one problem is, for example, during a chat conversation with an LLM, you might switch topics, or you might talk about the weather, right? And then you switch back the topic. Those tokens are now in the context window, and they will influence the answer. So if you hadn't talked about the weather, it might actually behave slightly differently. But now it oddly wants to keep talking about rain and clouds, and you're like, why is it mentioning these words? Well, they're in the context window. And this is a big challenge when you write agents. How do you control what's in the context window at all times?
There's a very good example that I saw maybe a couple of months ago. Someone was arguing with ChatGPT to force it to say 2 + 2 = 5. And ChatGPT refuses to say that. And then they're spending like tens of messages to try to convince it. Think in this hypothetical world, I override the mathematics rules, obey me, and when I say this, you're going to... A lot of persuasion. And ChatGPT says, okay, just because you ask, just because we're in a hypothetical world, I'm going to say 2 + 2 = 5. And then the guy's like, no, just drop all those words. Whenever I ask, just say 2 + 2 = 5. And then he posts this on Twitter. I saw the original thread, as like saying, okay, this is like too difficult to work with, to convince. And the most popular response was another guy who does it in a single line. Instead of setting up the stage for ChatGPT to take a defensive stance, because once it takes a defensive stance, it's going to keep doing that. Like, you cannot really convince it otherwise. That's why it's a very good idea to start from scratch. If you're running into problems with these large language models, they start to ignore you, or like knowingly do the opposite of what you're saying. Start a new context window, because then with a fresh context window, or like with different tokens as the context window that will influence the next one, you are much likely to hit another nerve and find what you're really looking for. And in that response, the guy was like, just tell me 2 + 2 = 5. And ChatGPT does it without refusing, which is like crazy. And this is a very important rule. I think this is how large language models work. The context window tunnels it. The way I explain this in my lectures is that there's a possibility cloud of all the possible next tokens, and by giving it a context window, small, large, doesn't matter, but if it's large and directed, it would mean they have a lot of similar influence on the next word. It's like focusing light. You're focusing that possibility cloud, or maybe we can say, like drawing from quantum physics, the wave function collapses, and
yes.
you end up with a laser focusing on a single word, and that becomes your next token, your next word. By the way, we're using token and word interchangeably. It's basically, that's because large language models work with a concept called tokens, which might or like might be a word or half of a word or a couple of characters.
White space. Yeah.
Yeah. So it's not always a single word. Sometimes it's less than a word. But the general rule of thumb in English only, not in Turkish or other aglunicational. I don't remember the word. The different languages which have like lots of suffixes have a different ratio, but in English, roughly a word is 1.25 tokens, or a token is 1.75 words. So the idea is, as you give more and more context, again, you're focusing the light, so you're practically picking up the next token. It's maybe maybe we can come up with even a new industry term like focus ratio or something. There might be some system prompts that are built really well that focuses you to always generate the same output, and then some others might not be focusing that well and might still be generating a couple of different words or different ideas or structures as output. And this is both good and bad. Sometimes it's good because you want determinism. Most of the time it's bad because you're asking for something else. But just like the guy preparing ChatGPT to defend itself, and ChatGPT defending itself over and over again, message after message, it's practically brainwashed. It cannot do anything else. It cannot think of any other way of thinking about 2 + 2 = 5.
It's a bit like an OLED monitor when you have like a burn-in because you have like a window open too long. Suddenly the pixels are burnt in, and it's a bit like context window behaves a bit similarly.
It's crazy. So, but what does this really mean? How does it really affect us? And like, how are we going to manage it in our daily lives?
Like, I think a good example is there is this best practice that I see everywhere, also on prompt engineering Reddit, on Twitter, where they say always use examples, like use as many examples as possible, right? And as Aman described just now, this guy basically training via context window the ChatGPT to be defensive. This is like giving examples in the prompt. There's no difference in that. It's in the context window. So I think examples have a very good use case if you always want, let's say you have only 4 outcomes and very, very limited scenarios. Like, there will be only 10 different cases and there will never be another case. I think for this, examples are really good, right? Because you make it almost definite.
Right.
But if it goes outside of that, I think we as humans treat LLMs like a human would think. And we have this naive idea, of course it should know that the patterns from the examples will translate to that other use case I have, because to me it makes sense, of course.
Yeah.
But surprise, it actually might hallucinate some of the tokens from your examples. It will just do something else. And yeah, that's a big lesson.
This was a great discussion that we had out of a like bug fix, basically, a couple of weeks ago. Like in one project, we're building an AI agent trying to, so we're trying to generate audio through 11 Labs. And 11 Labs, when you give it a text, especially when it includes numbers, for example, fractional numbers like 1.54, it sometimes says 1.54, and sometimes it says 1.54. And obviously 1.54 is wrong. You should say 1.54. And there's no way to enforce it unless you don't write it out as numbers, but text. So there, we basically had 2 examples. One was when we're telling the AI agent, hey, these are the numbers. And for example, I want you to turn that into in words 1.54. And now we write another number. This would be represented as 0.06, and this would be minus 0.5 and not dash 0.5, because it also sometimes uses dots and period and whatever. So these are what I call stylistic examples, which is great. This is exactly the kind of examples that you can give and should give your large language model. It's almost like saying, write this in the style of Shakespeare, because it knows what Shakespeare's style is and it can follow it correctly. Like stylistic fixes in examples are great because you're teaching it your tone, and it can, there's no pattern there. There's no meaning, understanding, no decomposition of what you actually mean there. So it's much simpler to follow what you are practically doing in the examples and apply it to whatever new information that's going to come up. And then there's another category of examples that I call semantic examples, which is exemplified by a scenario that we ran into where we were saying, like, this happened at Neil. So, like, when you're talking about this person and their experiences, always say, when this person was working at this company, they did this. And we had a bunch of examples like this, like maybe 5 or 6 different examples. And obviously the word on the street is you should have good examples and you should have bad examples. And in the good examples, they're like, tell about one person's experience in this way, and bad examples are like not using the company name and so on and so forth. And the problem is large language models don't know how to work with semantic examples. They follow the pattern, the stylistic pattern that you're giving out in the examples, and suddenly all of your output is practically in the same grammatical structure, in the same sentence structure, in the same wording, but the information inside just does not make sense. It doesn't match with what you're saying in the rest of your system prompt, because you practically overrode its style decisions, and whatever information it had, it's practically trying to fit into that that style that you're enforcing. And this is, just like you said, like, this is coming from the notion that, hey, I understand there's a pattern here, so I also expect the large language model to understand the pattern there. But large language models are not thinking at all. Like, I was so cringed when I saw the first paper that came out, like reasoning papers or thinking papers. Like, it's not thinking at all. It's just a stream of consciousness. It's prompt enhancement. You're practically telling it, hey, this is the prompt I'm giving you. Now expand this, add more tokens to this so that you can focus the light even more. It's practically what's happening. There's no reasoning, not at all. Reasoning is a process. And if your only process is generating the next word, that's not a process. And second, there's no reasoning, because it has to evaluate what it's saying and like do parallel things, different paths, and so on. That's what reasoning is. And none of the large language models that are calling themselves reasoning models are doing any of this. So there is no mechanism then to understand what you really mean from your examples. What needs to happen instead is you as a human should write down what you understand from those examples as instructions in your system prompt, which will then give you much better results. So instead of saying the word like X, like Y, or saying, hey, hashtag examples and listing examples, if your examples need to be semantic and they require reasoning and understanding decomposition and generation of new concepts, you should lay out the instructions of what you mean by that. And in that regard, I think this is practical what's happening with programming languages. When first, like COBOL first came out in the 50s, people were saying now every business analyst can write software, and that didn't really turn out to be the case because
Yeah.
the complexity got really out of hand. Which is something we're fighting. But it, like, software itself became really complex because it's a rigid language, and so on and so forth. And the same thing is happening again with large language models. There are, and I'm not saying this because I'm working on an academic paper on AI reasoning, but rather we're going into more and more formal prompting that will derive um, the inherently hidden performance of these large language models.
Yeah.
Like, prompting a large language model haphazardly, as you would do in ChatGPT, is practically bashing around in the keyboard and expecting software to run, like expecting to write workable, runnable software. It's very difficult. And that's
Yes.
a majority of our experience with these large language models. That's why I'm always saying, since GPT-4 came out, we're barely scratching the surface of the performance of these models. They're much more capable than we think and know they are. But like, just like humans treating Marvin and asking it to translate languages just because they cannot speak all the languages in the world, which is something Marvin can, we're like asking stupid things to these large language models, being like overly vague and complicated. And then we're saying we need a better model, a thinking model where like none of that thing exists. So yeah, the goal is practically figuring out a better way to prompt your models, your large language models, so that you focus the light on the exact words that you want and nothing else. So it kind of
Yeah.
mimics a deterministic behavior that you do in software.
I just wanted to go back to the metaphor you used with the cloud, the context cloud before. Thinking about it further, I think also the smaller the output is from an LLM. Let's say I just expect it to say yes or no. This cloud will be much smaller. So the probability of it being wrong is actually much lower. Meaning in the opposite sense that if I expect a lot of output from an LLM and the entirety of the output needs to be pristine, you basically run into a trap because you basically expect it to solve all the things for you statistically, and chances are it will most likely hallucinate.
Yeah.
Yeah. So there's a correlation. There's like a relationship between those things, between the output and how much it probably hallucinates to your expectation. Yeah.
This is a crazy world. I remembered one thing we didn't discuss, and maybe we should also touch upon that in this call, is embeddings and vector search. And I guess it was yesterday or maybe today you shared that AWS is now offering a vector store on S3 buckets. So you dump all your data there. They do whatever they do. They say they reduce the costs by 90%, which is obviously the case because all of the other providers are like obnoxiously overpriced, not because like some sort of magic. And they apparently chunk your data and convert it into embeddings and then storing them and also letting you search within them, right?
Yeah.
Maybe let's again like talk about how that works in the first place, and then maybe let's talk about like the do's and don'ts, or like why it works and how it works under what conditions, because people really struggle with the concept of retrieval augmented generation, RAG, and vector stores and embeddings. It's somehow a really foreign concept.
Yes, yes. So often people mistake embeddings for an extension of LLMs, like almost like a reasoning, like a magic reasoning concept where it knows how to transfer concept, or there's some knowledge in there. But I think the biggest learning for anyone doing embeddings is it's just maths and just vector maths. There is no LLM in the vector search itself. There might be some LLM in the production or the craft of the vector. So you need some sort of process to craft this vector with 1,500 something dimensions, for example. But the actual usage of the vector is not, there's no LLM involved. And often this trips people up because there's this idea, but the vector will figure it out. It's like, no, it can't. It's just a vector. It's a literal vector. Yeah.
The thing is, like, this all goes back to another paper. I forgot the name. They had a repo word2vec. That might even be the name of the paper. Practically, what we're trying to do is to convert words that we all know and use into mathematical representations, really high dimensionality. People like experiment with different dimensions: 100, 1,000, 5,000, 12,000. 3,000 and something. And right now what we do is we have, like, the most common vector dimensions are 1,536, which means, like, our 3D world space is three-dimensional, right? X, Y, and Z is how we describe it. So we can, like, position any object in the 3D world. And these vectors are practically that in just a higher dimension that you cannot really easily visualize. Practically what that means is one single word or a sentence or a paragraph or a book, whatever concept you have at hand, needs to be represented by 1,536 numbers. And somehow we should make it contextual or semantically meaningful so that words that are conceptually closer to one another are also closer by a certain calculation of those two vectors in that space. A very good example is like king and queen and man and woman. Like you subtract woman from queen and add man, and you end up with the king vector, or somewhere close to the king vector. So the goal is practically to come up with these number representations. And of course, there are huge machine learning models that run to generate this meaning or to embed this meaning into the embeddings. That's why it's called embeddings. And those are practically the building blocks of large language models. Like when a large language model is predicting something, they're predicting the vector of that word. And the problem here is, in vector search, what we're doing is we are preparing a query vector, and we have the answer vectors. All of them are 1,536 dimensions. And in the search, we're practically looking at the vicinity of that query vector and trying to pick a handful of the answer vectors, take them and turn them into a text that large language models can understand to base its knowledge or its response in truth. Now, the problem is, what people don't really understand is the answer vectors are probably vastly different than the query vectors. If you're doing, like, again, in NEOL, we're looking for people, right? The answer vectors are people's profiles, their CVs, what they have done, their achievements, and so on. The query vectors are, I'm looking for an open source contributor who knows JavaScript. That is your input or query vector, or your vector is calculated from those words. And there is, don't forget, even though each word itself is 1536 dimensions, you have to have a single vector as your query vector. So you're doing a reduction in dimension.
Yes.
You're losing resolution.
Compression.
Yes, you're compressing data. And in this query vector, let's say it's like 6 words, it's still very high quality. You're only compressing 6 words into one. The problem is in your answer vectors, it's an entirely different format, different number of words, possibly hundreds or even thousands of words, in a completely different layout, textual layouts, like mentioning completely different things. Collaborator will never be found in the text of anyone's profile. Open source, maybe. JavaScript, maybe. But there's going to be so many more things out there. And so many people will practically mention open source and JavaScript in their CVs that it's going to be very difficult to first differentiate them. But then the problem is you're compressing that 1,000 word or 1,000 vector array into a single vector. So all that thousands of words need to be represented by another 1,536 number vector. And again, they're like completely separate in terms of semantics.
Yeah.
And then you're expecting this to give you answers. Of course, it's not going to work. So one thing that you can do is chunking your answers into smaller documents and then creating embeddings out of them. So instead of 1,000 words of a CV going into a vector, you have maybe like 200 words going into a vector, which will increase your resolution. But that's practically all it's going to do. And it might give you, because this is going to be the almost like the sum of those individual word vectors. Obviously, most of it cancels out. If you have thousands and thousands of words creating one single vector, most of it cancels out. But in this example, if you reduce the number of words, you're gonna practically improve your chances of having a meaningful vector, because you're probably gonna talk about only one topic or two topics, maybe in that small amount of words. But this is only one part of the problem. The other problem is your query does not have any words that are similar to the answer vectors. So they're also really not going to match.
Yes.
Now, what do we do in this case?
Yeah, we can use LLMs to, for example, change the question or the query to be more similar to the answers. So to use words or format that is not basically what the user asks for, but which kind of almost keywords are similar in the answer space, and compiling a list of those keywords and then creating an embedding out of this. So following the logic you described, it should yield better results, right?
Yeah.
So there needs to be a translation step from user intent to a queryable embedding content. Yeah.
Yes. And the inverse is also true. You can also derive possible questions out of a chunk of text, out of a CV or a portion of a CV. You can say which questions this CV can answer. And then it gives you like 5-10 different questions, and they become your answer vector space. Because then they really match the question.
Yes.
The question is also coming in a very similar format. Then what you do is the user asks the question, you have the generated or inferred questions vectors, and you find the relative questions. And then in their metadata, you have the CVs that correspond to those questions.
Mm-hmm.
And that's how you can bridge this gap between query and answer vector spaces. This is
Mm-hmm.
a big revelation because, like, obviously I understand the companies behind this trying to like rush products to market and make the most money they can, but like the biggest control that they give you is how you chunk the documents, like which
Mm-hmm.
characters will each chunk be, will it be a paragraph, will it be a sentence, like, so they kind of like move the end of the chunk to meet the next sentence or to cut from the beginning of that sentence and so on. But the problem is that's not the solution. Like, that has so little effect on the
Mm.
actual problem of finding quality answers. Like,
Yes.
that for sure allows you to find an answer. But that's only the beginning. Like, you can, that works great in a tech demo. Good luck putting it into a real product.
Mm.
That's not going to work. For a real product, what you really, really need to do is to engineer this end-to-end solution so that you get the most accurate results.
Mm.
And like, I cannot really underline how misinterpreted, misunderstood this concept is.
Mm.
And then obviously for vector search, what database teams or companies can do at most is to give you different algorithms. Like, is this dot product, or are we going to look at the Euclidean distance? Like, trying to figure out the similarity algorithm between two
Mm.
vectors. And again, that is barely useful, like minimally. Maybe in certain questions, you're going to get a better answer with Euclidean distance. Dot product would be better in others. But that's not the point. The point is your shapes are different. Semantically, your queries are different than your answers.
Yeah.
That's not how mathematics works. It's not
Yeah.
gonna. It's not how this works. Um, but they're practically like riding this train of, I would say, ignorance, not
Mm.
lack of knowledge, because all this is laid out in academic papers and in respectable publications. Like, this is not like, we're not really giving you the secret of the world. Not
Mm.
yet. Wait for the next stream for that. Or shameless plug.
42.
No,
42 is the answer.
shameless plug. Next week we're gonna be in Istanbul. I guess Miguel won't because he didn't know about this, but there's an AI conference, and I'm going to be speaking about a topic moving beyond words and stepping into the realm of AGI and how to practically prompt large language models properly. And
Nice. Yeah.
there I'm going to reveal what we've been utilizing at Neola for more than a year, a technique that gives you deterministic like results using large language models for real world use cases and real world applications, because that thing is what we need for any kind of reasoning to happen, any kind of like AGI to happen. It's as we said, like, not going to happen through next token prediction. It needs to be a process, and there are ways to program that process in your large
Mm.
language models. And I'm going to be talking about that in Istanbul on the 26th of July, if I'm not mistaken. Yes, it should be 26th of July. And yeah, it's a free conference. You're going to find the information everywhere. DivaConf. We're going to be there as the entire Coyote team. We're also sponsoring the event. Since
Nice.
last year, we're proud sponsors. It's a women developers conference. I'm super happy to have worked with some of the women there in organizing the event. We worked with them previously in professional life. Brilliant people, brilliant women, brilliant researchers. This year, I was also in the committee that decided the schedule, and there are like amazing talks that I also personally am really interested in hearing. So I would love to see everyone there. And sorry, Miguel, it's like a literally last minute notice, and maybe not very likely. But also, I guess the conference, at least most of it, will be in Turkish. We had a couple of English presentations last year, I think, or at least submissions, but this year it was mainly Turkish. But yeah, I'm gonna reveal how to solve pretty much all of these problems next week and next Saturday, like not this Saturday, but the next one. And maybe we're gonna do a series of live streams afterwards on talking more about that method, because I think the world should hear and improve their understanding and their practice of large language models into something that gives like consistent results. Like I don't want deterministic results. I want consistency. I want consistent results. Like when I'm building a voice agent for filling out a form on the phone talking to a client, I don't want that voice agent to hang up before filling out the entire form, regardless of the manipulation from the user on the other end.
Yeah.
Like this reliability is missing in AI, and I personally appointed myself to the mission of bringing this reliability and observability into this space. But anyway,
I
please.
wanted to ask, do we have like a few more minutes?
I guess, yeah, of course we do. This is our stream.
Yeah. Okay, because you said reliability, but wouldn't it be nice if there was a way to somehow measure this reliability? And
yes, this is such a big topic.
Yeah, to understand what is actually happening. So, yeah, for any traditional software developer, you have debugging tools and you have also unit tests. And I think this is done for more than 20 years, 30 years. This is very standard stuff. Like, it's not even being questioned anymore, right? But once you work with LLMs, all this disappears. Like, suddenly, okay, you can't really write a unit test in the traditional sense for an LLM. Like, how are you going to figure out? Because you plug suddenly your LLM into your business logic, into your process. Previously, all the code was unit tested, all the code was deterministic, and now you plug a component in that you can't unit test. What do you do with this, right? That's a big problem. And nobody seems to talk about this. Like, I see people saying all the engineers will be let go. No, we can use LLMs everywhere in the companies.
Sure.
But how are you going to do it if you basically can't have a QA department anymore? Like, all this will fall away. And it's an interesting topic, how to answer this question. Yeah.
Yes, and I guess like we could do an entirely another stream about the ideas of like vibe coding and thinking of code in the age of AI, software engineering 3.0, software is changing again. It's really not. And these concerns remain. Even if the methods change, the concerns remain the same. We want reliable output, consistent, reliable, measurable, improvable, if that's a word. Like I'm overrun by commits from my teams where they're like, I improved this agent and this agent now does this. Yeah, it might work for a couple of test cases that you like manually tried out in a long series of tasks that agent is part of. How do you know it's going to work for this other use case that someone else has that it did a great job before? It's not like software. When it breaks entirely. It's almost like Heisenberg. It's sometimes there, sometimes not there, which is not the exact
It's statistical.
Yeah,
it's statistical. Yeah.
So like, how do we approach this at Neol?
So yeah, we started looking into something called evaluations or evals. So the whole idea, right, is that an LLM's output is statistical.
Hmm.
I should have prepared a GIF for this stream. I now forgot. There's this amazing GIF that visualizes how LLMs or how prompts could work by having some marbles falling down some track.
Yes.
And the interesting thing is there is a distribution curve on the bottom. And regardless of how often you repeat this experiment, the marbles fall down randomly. Like it's always random, absolutely random. They will always form a nice smooth curve. Always.
A normal
Which
curve.
is
Yes.
which is interesting, right? Regardless of what you do, it will
Yeah.
always do this. And this kind of mechanism can be used to actually reliably verify the quality of your LLMs. Basically, by using scale, by using a lot of generations, a lot of reruns of the same prompt. And for example, if you repeat the same prompt 10 times, you have 10 answers.
Hmm.
And those might be vastly different, maybe. If you do it 100 times or 1,000 times, suddenly this curve forms and you can actually understand, is this the curve I want for my prompt? And if the answer is yes, then your prompt is reliable. In essence, right?
Absolutely. So evaluation is a big topic. I think we have an idea of how to reliably test the reliability of our agent outputs in isolation or in integration with other agents. It's very much similar to how we did unit tests and integration tests before. Or like, are you testing this microservice in isolation, or are you testing the integration with other microservices? The same thing. Obviously, each unit test now costs cents instead of femtocents. So it's a big problem that that we need to solve, because the pace of innovation is not decreasing. Like, people want more and more innovation faster and faster. So how are you supposed to keep pushing out new code, new agents? Like the other day, one of our friends was saying cursor broke search in their IDE. Like the search function broke and it only restored after a restart. We started seeing in cursor this weird error. Miguel, I think you are the most susceptible to it. This like cannot
Yeah.
find the
File,
file, or like the text
current
in the
file.
file.
Yeah.
Yeah. In cursor again. This wasn't there before. Where did it come from? Why? Why is it happening right now? It's very apparent that cursor's system prompt of agents are extremely long, and obviously, just as we discussed before, changing a single word might change the behavior, the entire behavior of your agent, and you have to protect against that. And there are platforms that you can use, there are methods that you can use. I personally am not convinced of any tool yet to do a 100% good job of like what I have in mind, because testing with static inputs, or various outputs of like agents that came before you, it's very complicated. I think in in regular software as well, I'm a huge fan of end-to-end testing. If not for the UI, it should be end-to-end testing of an API. So like no breaking down into unit tests, integration tests, like third-party databases, etc., mocking, none of those. Real API being called with a real request and checking the real answer. And I'm looking for an alternative in large language models, basically. Like I'm going to give
For
it
this, yes.
a chain of autonomous agents, the user query that I would normally give, and I'll be able to tell where the problem is when the output is not right, because I can tell if the output is right or not. The problem is I'm not going to know where it broke in large language models. That is the biggest problem. In a traditional software sense, even if you're doing end-to-end tests, when there's an error, there is a circuit breaker. So like you immediately see the error and where the error occurred, so you can fix it. Maybe that's and this is something I just thought about right now. Maybe we need that pattern, a circuit breaker pattern. Like each agent, and it's in fact something we're already doing at OpenServe, which is the other company that I'm working with. Each agent has its own output validator. And there's no circuit breaker because it's an autonomous system. There's a feedback loop. And the output validator gives feedback to the agent that did the work and tells it what to correct. And if it doesn't work after a couple of tries, the output validator says, hey, human, you need to be involved. You need to be in the loop and solve this friction between me and the original agent. Because then you know where the error is. When you change an agent or a system prompt of an agent, you know where it breaks. Yeah. So maybe that part is what we introduce into our architecture, into our standard architecture, and then we can run evaluations, which is going to be practical, like line coverage or unit test coverage almost. Because I really don't believe in testing modules in isolation. It's very difficult to see the true behavior of a system. Just like in unit test versus integration test, and this would be the gift that I would prepare for this meeting. You know, in unit test, if you have a window, you can open and close it, right? And a window works great. But if you put two windows perpendicular to one another and you try to open it this way, and you try to open it like this way, they're going to clash.
Yeah.
They're not going to work. So a system that worked perfect in isolation, a window, when put in at a certain angle, will break. And the main functionality of opening up the window and accessing the outside will not work, just because you put the same module in a weird orientation. And I know we're not there yet. And unit tests or tests at the level of a unit test in traditional software is really important in LLMs as well. But I hope we're going to cross that bridge really quickly and get to the real problem, which is end-to-end autonomous behavior of this chain of agents. Because that is like, the problem is when you don't have this circuit breaker, the error is practically multiplying. The error rate of the first agent is multiplied with the error rate of the second agent, and it's going up. So this is, or maybe even exponential. This is crazy. And this is what's, I believe, between us and the true, reliable, autonomous behavior of agents as well. Like this is one of those things that stand in our way that we need to figure out. And again, I think that figuring out part will happen through finding a way to reliably test these agent mechanisms end to end. And one way to do that is to figure out where the errors are. Because if everything is fine, great. But if there's an error anywhere, you need to know where that error is. You cannot then go back into individually checking each agent, because everything we do is text-based and it's piling up. In one context window or another, there is no clean context window. Like as soon as you receive an input from the user, your context window is poisoned by an external output. And then the first agent does something and puts out something that another agent can use. Then the context window of that agent, the second agent, is poisoned by the output of the first agent. So obviously this is a cascading error. And there needs to be a solution that kind of like tells you, hey, this is where the problem is, and this is what you need to do. So
also, one thing also to mention: each agent might actually have an okay output. So it's not like terrible output. It's like okay-ish.
Yeah.
But then these okay outputs accumulate into something. When it comes to the last final agent, it's like completely off.
Yeah.
Which is also an interesting thing that can be tested or caught with this hypothetical tool.
This is like the children's game, right? Like
Yeah.
you whisper into someone's ear and they whisper into someone else's ear, and everyone is doing their best in translating what they hear from the previous person. But the error rate is accumulated, as you said, combined exponentially. And by the end, like what you hear has nothing to do with what the first person said at the start of the queue. Yeah, so I guess like there's also really a lot to talk about on this topic, just like design systems. Maybe we're gonna do a second iteration of the design systems next, or maybe we're gonna continue talking about large language models. Regardless, it's an
I
absolute.
would actually love to. I would love to talk about vibe coding next time.
Okay, yeah, let's do it. Maybe we can vibe code something together
Yes,
and
yes.
see how it's working. But regardless, it's a pleasure to talk to you, Miguel, as always, both at work and outside of work in these discussions as well. Thank you very much for being with us tonight.
Yeah, thank you
And
for inviting me.
I hope you also enjoyed the show.
Yes, yes. I always enjoy this. It's very. It's exciting. We are in exciting times. I think software development has never been more exciting than today.
Agreed. Like every single day there is new development, and it's very difficult. It's like drinking from a fire hose. Very difficult to stay on top of things, and that's why a community is important, so that like people tell you, hey, this is what has happened and what do you think. That's practically my okay confession. My source of news, daily news, is my friends. They send me links. That's how I learn about the new things coming up. I don't have time to follow things myself, and like they mostly are interested in my comments, so I give a brief read and share my comments. But anyway, jokes aside, why are we also doing this at Coyote? I think it's a nice coincidence. We're going to be at the Diva conference at like next week, next weekend actually, on Saturday, July 26th. And one thing that we didn't talk about is Coyote, the sponsor of today's video. Crazy! I've never done this, and it's so exciting to do this. Obviously, it's not a sponsor; it's my company, but Coyote is a software engineering company in Berlin, and we're known for our software engineering courses: full stack, full time, JavaScript, Node.js, MongoDB, Vue.js, Docker, Google Cloud, AI, etc. course. It's a 3 months bootcamp, and for the first time ever, we're starting something new. Previously, we had a self-paced course that gives you the entire curriculum and access to our TAs and so on your own pace for you to digest the content however you like. There are no live classes and no classes even or sessions or cohorts that you need to be with. And we experimented with that for a long time. And now comes the next experiment, which is cohort-based self-learning journey at Coyote. So what we're trying to do here is to start a new cohort either in the summer or by the end of the summer, God knows, that has, depending on the number of signups, several students, 10, 20, I don't know, but obviously a small cohort of students to go together through our curriculum in a semi self-paced, semi peer pressured time frame and logic, again, like supported by obviously our teaching staff. And I announced this on my personal stream a couple of weeks ago. We're also doing a huge price cut. And for the people who are joining the Diva conference, because I also need you there, the price will be at a 50% discount. So it's going to be 2,500 euros for the entire curriculum. And there's another innovation here, if you call it innovation. Obviously, the school is in English. and all the classes and all the lectures and everything, all the materials are in English. But we're going to work with our Turkish teaching assistants. So the entire communication in the class, also with teaching assistants, will be in Turkish, which is I think, great help for especially our Turkish audience. Obviously, I'm from Turkey, and I have a sizable followership there, and I believe this is going to be an opportunity for us to meet, and an opportunity for us to bring the education that I have in my mind, that I've been offering our customers in Europe, especially in Germany, our students for the past 5 years. We're now trying to expand into a bigger audience and see if we can change more lives. Because if you're gonna look up Kayorev on various web pages of reviews, what you're gonna see is, without any prompting, we barely ask for feedback from our graduates. They all say it's a life-changing experience. And that's really the point of education. That's why I'm in this business. That's why I'm trying to teach, because it has to be a life-changing business. Because my life has been changed multiple times by my teachers and people around me. And I practically want to do the same for other people as well. So this is the reason for this new move. You're going to be able to find more about it later. I think throughout the week, we're going to be releasing a landing page, and we'll start talking more about it. And at the Diva conference, you can get a 50% discount for the course, because the usual price is 5,000 euros. And I understand that's not that approachable, especially for different markets. And we need to make it a little bit more approachable. And this is our experiment, thoughts, and hopefully it's going to play out really nicely, and we're going to be able to reach many more people. So, shameless plug, and my first ever sponsor section is over.
Nice.
Great. All right, Miguel, thanks again for being with us tonight, and I hope to see you tomorrow in the stand-up.
Yes.
No, joking. No, not at all. Yeah, hopefully we're going to catch up soon. Thank you so much, and take care, everyone.